Hello students, my name is Nisha SP, Assistant Professor, Department of Chemistry, GM University. Today we will learn about determination of chemical oxygen demand, that is COD, of industrial wastewater sample. So first let us discuss about the theory of this experiment. So basically COD stands for chemical oxygen demand. It is the measure of amount of oxygen which is required to chemically oxidize the organic and inorganic matter in the water. So COD is commonly used in the environmental science and water treatment to assess the water quality or water purity and level of pollution, especially from the industrial and municipal sources. So high COD value indicates high concentration of oxidizable pollutants, which can lead to oxygen depletion in the water bodies, which definitely going to negatively impact on the aquatic life. So COD is typically measured in milligrams per liter, that is mg per liter, which is also called as ppm, parts per million, and it is determined using strong chemical oxidizing agents like potassium dichromate in the acidic condition. So talking about the principle, so this principle involves determination of COD when the wastewater sample is treated with a known and excess amount of potassium dichromate in 50% of H2SO4. The maintaining acidic condition is very important here, and in presence of silver sulfate, which act as a catalyst, and mercurous sulfate. This is used to eliminate any kind of interference arising in the titration due to the presence of chloride ions. The dichromate remaining unreacted in the solution, that will be treated with the standard solution of FAS, that is ferrous ammonium sulfate, using ferroin indicator. So this is the procedure. In this, the part A or the first part involves preparation of standard more salt solution or FAS solution. So first we have to take a empty beaker. In that, take sufficient known amount of FAS and dissolve the salt into 100 ml volumetric flask. Add half a test tube of sulfuric acid to dissolve the crystals and dilute the solution with millicube water and shake it for uniform concentration. So this gives us a standard more salt solution or FAS solution for titration. In the part B, we will be dealing with estimation of COD. In this, first we have to do back titration. So whatever the amount of potassium dichromate which remains unreacted after oxidizing the organic or inorganic matter of the water, that will be titrated here against FAS solution. So for this, first we have to pipette out 25 ml of the wastewater sample into conical flask. Then add 25 ml of standard potassium dichromate solution. To that, 1.5 test tube of dilute sulfuric acid containing silver sulfate with constant shaking or constant stirring. Add 2 to 3 drops of ferroin indicator and titrate the mixture against standard more salt solution taken in the burette until the solution changes from bluish green to reddish brown. Repeat the same titration to get 2 more concordant readings. The next step is blank titration. So blank titration is usually done to find out the exact concentration of K2Cr2O7 present in the actual solution. So for this, pipette out 25 ml of standard potassium dichromate solution. To this, add 1.5 test tube of dilute sulfuric acid having silver sulfate, followed by 2 to 3 drops of the indicator. Then titrate the solution against standard solution of FAS till the color changes from bluish green to reddish brown. So this is the observation and calculation part. In part A, this is regarding calculation of normality of the FAS solution we have prepared. So the first one is weight of the empty bottle and the FAS salt. Second is weight of empty bottle. So subtracting the second weight by first weight gives us the exact weight of FAS dissolved in the solution. So using the formula, weight of FAS into 10 divided by the equivalent weight of FAS gives us the normality of standard we have taken. In the second part is about estimation of COD. We have two tables here. First table is for 3 concurrent readings or trials of blank titration, and the second table is for the back titration readings. The 3 readings of back titration will be noted down here. So this is volume of FAS for blank titration, the volume of FAS for the back titration. So subtracting both the volumes gives us the exact volume required for the reaction. So this is the conversion factor. So solving the conversion factor and arriving at the exact report, that part we will discuss in the experimental part. So report is always reported in ppm or milligrams per liter. So the next explained discussion of the experimental part will be discussed further. Thank you. Welcome students. Now we will see the practical part of the COD experiment. These are the apparatus required for the experiment. First is the burette. Next pipette, 25 ml pipette I am taking. Conical flask. This is ferroin indicator. Next is potassium dichromate solution. This is wastewater sample containing the organic matter dissolved. This is FAS solution for titration, and dilute H2SO4 solution which has dissolved silver sulfate and mercurous sulfate in it. So this experiment consists of two parts. Part A consists of making FAS solution of 100 ml. So for that, first we have to weigh FAS. So take a glass beaker. So this is FAS, ferrous ammonium sulfate, and weigh appropriate amount of FAS. And note down this as a W1. Now transfer the amount of FAS weight into a 100 ml volumetric flask and add half test tube of H2SO4 and make up the volume up to the mark. So now I have prepared FAS solution by dissolving the FAS what I have weighed. Then after transferring, take weight of this empty beaker and note down it as a W2. So now I have transferred 25 ml of the wastewater sample into the conical flask using the 25 ml pipette. Next we have to transfer potassium dichromate also into the same conical flask using the pipette. Now add 3 to 4 ml of dilute H2SO4 containing both silver sulfate and mercurous sulfate, and 2 to 3 drops of the ferroin indicator. Since the quantity of the organic matter dissolved in this is less, we cannot see the intense bluish or greenish color. This will be yellow color. If we use some sewage water or highly impure water, we can see a clear or intense green bluish color into this. Now I will start the titration. I have taken FAS solution into the burette. the color has changed to reddish brown. So this is the end point of the titration. The next further calculation will be discussed. Now note down the burette reading and take it as a back titration. Now note down the burette reading and repeat the same procedure for 2 more times to get the concurrent reading. Now we will move towards the blank titration. So now we will do the blank titration, for which I have taken 25 ml of potassium dichromate solution into the conical flask using pipette. Now I will add 2 to 3 ml of dilute H2SO4 containing silver sulfate and mercurous sulfate. And again 2 to 3 drops of ferroin indicator. Since this is a blank titration, we are not taking any water sample here. This titration is used only to know the reaction of K2Cr2O7 with the FAS. So in this we will come to know the exact volume required for the reaction of only K2SO4 with the FAS, excluding the water sample. So there is a color change to red. Note down this reading and repeat the same procedure for 2 more times to get the concurrent reading for blank titration. Okay, now I will explain the last part of COD. So in the observation and calculation part, the first part we have part A for the preparation of standard FAS solution, where W1 we have taken weight of the bottle plus FAS salt. Second is W2, which is the weight of only empty bottle. W1 minus W2 will give us the exact weight of FAS we have weighed. Then to calculate the normality of FAS, we have to use this formula, weight of FAS into 10 divided by equivalent weight of the FAS. How we got this 10 is, we are doing it for 1 liter, that is 1000 ml, but we are preparing only 100 ml of FAS. So cancelling 2 zeros, we get 10. So that 10 we are using here for the multiplication factor. So solving this, we will get the normality of FAS solution we are using for titration. Then in part B, we will have back titration, the 3 concurrent readings, and blank titration. For that also 3 concurrent readings we will get as V1 and V2 taken as the average weight of the 3 readings. Then subtracting both V1 V2 gives us the exact volume required for the neutralization of potassium dichromate for COD. Then talking about the stoichiometric ratio, 1000 cm cube, that is 1 liter of 1 normal FAS will be equivalent to 8 grams of oxygen molecule. Therefore, Y ml of X normality FAS solution will be equal to Z grams of oxygen. So how to calculate this Z? That will be equal to volume taken into X, the normality, and into Y. So divided by 1000, that will give us A grams of oxygen, but that is for 25 ml only. Since we are titrating only 25 ml of the analyte, we are getting it as A grams per only 25 ml. Now we have to convert this to per liter. So multiply the value with 1000, you will get B amount per 1 liter or 1000 ml of the analyte. Then lastly, we need the results in mg per liter, that is ppm, parts per million. That is why the obtained quantity, just multiply it with 1000, you will get milligrams per liter. So finally the chemical oxygen demand or COD will be converted to the obtained value in ppm unit, that is milligrams per liter. So this is the desired result with unit. Thank you.